Hello, class. This will be the last of the recorded lectures for chapter 9, and it follows the chapter 8 pattern. So now what we're going to do is hypothesis testing with proportions, or the idea of a binomial distribution where you have a percentage or a proportion of something that's true or something that's false, that's something yes, something no. And again, because of the central limit theorem, we could approximate this proportion or binomial distribution if we're worried about the mean, which is the same idea of that idea of making that the proportion, uh, approximate it with a normal distribution and do hypothesis testing, just like we did throughout the other concepts in the previous sections. So with that, we'll split this up into two ideas. The first idea is calculating the critical value and comparing it to a z-score in this case. And then the second is to use technology to find the probability or what the book calls p-value. So with that, let me give you the example of the problem we're going to do here. And so this one here, we're actually going to use this example to calculate the critical value and compare it to this z-score idea. So here we have a survey for teachers, and it says 85% of them using virtual reality in a classroom would have a positive effect on education. So that's your proportion, right? 85. And remember, you want to convert it to a decimal, so that'd be 0.85. And then one education specialist believes the percentage is now more. So what they did is they ran a survey, and it looks like that 90%, more than 90% virtual reality equipment has become more available. And so she samples 500 teachers and finds that 470 of them believe that virtual reality has a positive effect. And so we got a lot of percentages here. And then the last thing is, can she conclude that the proportion of teachers who believe virtual reality is a positive effect is greater than 90%? So here we're going to do the hypothesis testing. So let me kind of remind everybody how this gets set up. Well, X is the, excuse me, the number of positive, right, in this sample of individuals. And if we go back to that, that would be 471. And then the N value is the total sample, and that would be 500. And then the sample proportion, or the p hat, as we've been calling it, is the X divided by N. And the population proportion is our p-value. And so again, we have the same criteria that we had in the central limit theorem, that all these have to be true. Is it simple random? You sure do hope it is. Is the population 20 times larger than the sample? I think there's more than 500 teachers. Times 20 would be what? 5,000, 10,000 teachers. I think there's more than 10,000 teachers, so we should feel good about that. And then you compare these two ratios. And again, if you do that, you would find that this assumption would be okay. But what I really like to focus on the calculation. And so here you see our test statistic. And you can see that our test statistic is, again, this idea of a z-value given the certain criteria and the experiment or survey that we're doing. And we're going to make a decision, either reject or do not reject the null hypothesis. And you can see same types of tests, left tail, right tail, two tail. And so we'll end up doing a conclusion with regards to this. So let's set this up and do the calculation. So let me pull up the whiteboard here. Before I pull up the whiteboard, again, don't want to focus on this too much, but again, you could see that if you do n times p0, you have 450, and 1 minus n times p0 is 50. So you could see that the assumption is satisfied, and we can walk through the hypothesis testing. We're going to use an alpha level of 0.05 or 5% and walk through this calculation. Okay, so let's get this all set up here on the whiteboard. So what we've set up from the problem at hand is now our p value for the null hypothesis is 90% or 0.9. And our H1, which is all alternative hypothesis, the claiming that it's going to be greater than 0.9 or 90%. So what's our p hat value, right? And the p hat comes from the experiment. And the experiment stated that out of the 500 teachers, 471 out of 500 think that it would have a positive effect using the technology in the teaching. And so when you get out your calculator, you would see that would be 942. And so what is our test statistic, right? T-test. So this test statistic, and the book calls it a z-value, which it is, because if you think about it, here what it is, and again, you'll find this in the slides or in the ebook, it looks like calculating a z-value assuming a normal distribution, 1 minus p0 all divided by n. And so in this case, I forgot my little p0 there, but that's our p0 that we're talking about from the hypothesis testing. And so the idea is that if you think about it from the old z-score calculation from the normal distribution, we had the point minus the mean divided by the standard deviation. So you could see analogous is our p hat is our point from our experiment. And again, analogous to this is our population mean is our p0 that we're doing. And our standard deviation, again, is the central limit standard deviation for proportions. So you could see everything's predicated on that fact that you could use the central limit theorem to do these approximations. And so we just have to kind of walk through the calculation. So let me erase this now so I have a little bit more space to plug some numbers in. Okay, so when you plug some numbers in, you would have z equals 0.942 minus 0.9 all divided by this crazy square root thing, right? So it's 0.9, 1 minus 0.9, which is 0.1, divided by 500. And if you look at that, you would see you would get a z-score of 3.13. And if you think about that, that's the z-score that's way, way up here, right? 3.13. And so the idea is, what is our comparison? Well, again, when we talk about these comparisons using the critical value method, again, let me remind you, it looks like this. So again, you calculate the test statistic, and then you make a comparison. Left tail would be less than, right tail would be greater than, and then two tails, you're going to compare the two endpoints, right? So the high end would be greater and the low end would be less than the negative version. And what is our conclusion? Well, if step 4 is true, you reject the null hypothesis, and step 4 is false, you do not reject the null hypothesis. So to finish this one up, what is our comparison z-score? Well, according to our problem, we were using an alpha level of 0.05 or 5%, right? So hopefully this one looks, but if you think about what we would do here, again, that would be 90 here. And then you would have 5 at each one of these tails. So again, you could look this up in the chart. Or you could look it up with your technology, but you would see that that Z-score is 1.645. So the key is here is 3.13 greater than 1.645, because we have a right tail test, right? And the answer is yes. So you would reject, or you would reject the null hypothesis. So you would make the assumption that it is greater than 90%. So you could say that the alternative hypothesis is true. And you could see that with z-scores, 3.1 is way bigger than 1.645. So you would even feel more confident because the values aren't very close together with regards to that. So that will end the first of the 2 lectures of this section. So this is the critical value calculation. That's the one that I had to use because we didn't have the fancy technology. But what I will show you in the next recorded lecture is to use your calculator or the spreadsheet to calculate the p-value and compare that and make the same type of conclusion.